Hello everyone. In this we are going to see another problem on coplanar concurrent force system which was asked in the year 2018. Determine the resultant forces acting on the structure at point O. So this is the point O we have. We have to determine the resultant which is acting at point O both in magnitude and direction. So now this is one structure which is being given here. This is one structure what is being given. So here one force of 800 Newton is applied and another force of what you can say 600 Newton is applied, which is moving away from the point O. So now this length they have given, that is 6 meters, and which is inclined at an angle of 60 degrees, and this horizontal they have given it as 3 meters. So this is the data what they have given. Based on this data, let us try to do the calculations. So if you see this force is horizontal, we need not calculate any angle. Then next is the 600 Newton force. At what angle it is inclined, so that has to be calculated. So as to calculate that, what information we have, that is we have this horizontal distance as 3 meters and this inclined distance as 6 meters. So it is somewhat like this. So let me draw it somewhere here. So this is one angle we have, this is another we have, right? This is point O we have, this is C we have, this is A we have. So now this angle, or what you can say theta, has to be calculated. So this distance is given to us, that is 3 meters, and this inclined distance, that is 6 meters we have, and this is inclined at an angle of 60 degrees. So now we have to calculate what is this angle theta. So what we can do now, we can take this vertical, so from here we can take this vertical, right? I will take mark it as B, right? So from this triangle OCB we can calculate this value of theta. So if you want to calculate this value of theta, you require this distance now. This distance is required, as well as this vertical distance is also required. So as this distance is 6 meters and this angle is 60 degrees. So if you are going to resolve it along horizontal now, this is cos 6 meters we have, right? This angle is 60 degree. So if you resolve, this will be 6 cos of 60 degrees. And if you resolve it vertically away from the angle, it will be 6 sine of 60 degrees. 6 sine of 60 degrees. So now based on the triangle OCB, we can calculate the angle now. So as to calculate this theta, this opposite side is known to us, adjacent side is known to us. So therefore what we can do now, we can calculate this theta value. So therefore this tan theta, that will be equal to opposite side is, that is 6 sine of 60 degrees divided by adjacent side, that is 3 plus 6 cos of 60. 3 plus 6 cos of 60 degrees. So based on this, you can calculate the value of theta. So therefore theta will be equal to we'll be getting answer as 46.1 degrees. This is the value of theta. Next, if you see, we will simplify this and we'll try to get the solution. So if you see the free body diagram of this, so what happens is, this is point O I will take. So this one force is acting at an angle of it is acting horizontal, that is 800 newtons we have. Another force is acting moving away from the point O, that is 600 newtons we have, which is acting at an angle of theta. So if this is theta, so then this angle will also be equal to theta. So just now we had calculated this theta value, that is 46.1. Then next, this is the vertical we have, this is the y-axis we have, and this might be your x-axis. So now we have two forces which are acting now. So based on this, let us try to calculate the resultant, what you can say, magnitude and direction of the resultant force. So let us try to calculate summation of f of x. So that will be equal to, if you see this force 800 Newton, you see the arrow, it is going to move towards right side. Therefore it is plus 800. So we need not resolve. Why? Because already it is acting horizontal itself. Then next we have 600 Newton force. If you see the arrow, if you are going to resolve along x-axis, it is going to move away from the it is going to move towards left side, therefore it is minus. minus 600. We are going to resolve along the angle, therefore this is cos of 46.1. So if you simplify this, we will be getting answer as 322.64. Then next we will take another equation, summation of f of y. So this force component we cannot have along y direction, as it is purely acting in x direction. If we resolve, it will be 0 itself. Then next is we have to resolve this force, 600 Newton force. So this will be minus of 600, what you can say, sine of 46.1. So if you simplify, we will be getting answer as minus 288.22 newtons. The next, based on this, what we can do, we can calculate the value of r. So r will be equal to square root of summation of fx square plus summation of f of y square. So therefore this will be equal to 322.64 square plus 288.22 square. So finally, if you simplify this, we will be getting answer as 432.63 newtons. Then next we have to calculate the angle theta. So theta will be equal to tan inverse of summation of f of y divided by summation of f of x. So therefore, if you are going to have this, tan inverse f of y is 288.22 divided by 322.64. So therefore this theta value will be equal to 41.77 degrees.